Spend some time talking about rates, ratios, and proportions today. I want to use something called the means extremes theorem. The means extremes theorem says this: if we have these proportions, A over B is equal to C over D, then what needs to be true is that AD has to be equal to BC. Let's just do a little bit of practice here and see if this doesn't work. We agreed that 1/2 is equal to, and whatever you think 1/2 is equal to, I'm going to use 50 over 100. You can use whatever you want. It has to work. 2 times 50 is 100. 100 times 1 is 100. 100 equals 100. So you're like, okay, well, that's funny that that worked, but that's just luck. It's not just luck. 2/3 is equal to 6 over God, wow, that's embarrassing. 6 over 9. Wow, that's really embarrassing. Sorry, you guys. It's just proof. I'm doing it in my head just like you are. 3 times 6 is 18. 2 times 9 is 18. 18 equals 18. So what does that give us? What does means extremes theorem give us? What does it allow us to do? Well, it allows us to solve proportions in a much easier manner. So now what we're going to do with our proportions is we're just going to look at them like this. When we set up a proportion, we're going to say, if this proportion is to be true, then this times this must be equal to this times this. So what does that mean to us? Well, z times 1 is equal to z. If you notice, I put a cross through my z, which means not equal to 2. 3 times 8 is 18. Right? And also, if we're talking about these letters, also, so when you make your z this way, that means this cross through it means not equal to 2. It means I don't mean 2. And when you make a t, see how this looks like a plus sign? When you make a t, put a little hook on the bottom of your t, and that's t. And this hook at the bottom means not a plus sign. So, okay. Z is equal to 18. And isn't that true? That 3 over 18 is 1/8. It is true. So let's try one that's just a little bit more complicated, but we're going to use the same method that we used before. And we're going to say that 7/2, 7 over 2, is equal to f plus 3 over 12. Right? Now, this is not complicated, but we have to look at this clearly and think our way through this a little bit. We have a quantity up here. This is the quantity f plus 3. So we are going to do that distribution that you were thinking of. We're going to multiply this 2 times this quantity, and we're going to do this 12 times this 7. And it's going to end up looking like this, isn't it? 12 times 7 is 84. And 2 times f is 2f. 2 times 3 is plus 6. So hopefully you see that I'm multiplying this 2 times this, and then the 2 times that. All right? So it's the distributive property of multiplication over addition. So I distributed this multiplication over this addition right here, and I said this should be a 6, so it needs to look like a 6. Sorry about that, not a b. That's a 6. All right? We start to do our algebra here. We do -6 here, -6 here. We get 78 is equal to 2f. And what is that? What is that? Let me check real quick. So f is equal to 39. Sorry, I just can't. Sometimes I start doing algebra and my ability to do arithmetic just falls into the toilet. So sorry about that, but I wanted to make sure it was right for you guys. So hopefully that makes good sense. So remember, means extremes theorem says that if we have a ratio A over B is equal to C over D, then what we should be able to do to solve that ratio is cross multiply this way, and they should equal each other. All right? Good work, you guys. If you haven't already subscribed, please subscribe, and you know your comments are always welcome, so thanks.